May 27, 1942. The aircraft carrier USS Yorktown limped through the entrance to Pearl Harbor, trailing an oil slick 10 miles long, black as a funeral ribbon across the Pacific blue. She'd taken a 550-pound armor-piercing bomb at Coral Sea 8 days earlier. The weapon had punched through her flight deck 15 feet inboard of the island, penetrated 50 feet into the ship before detonating above the forward engine room. 6 compartments were destroyed. 66 men were dead or dying. The gears controlling the number 2 elevator were damaged. Radar was gone. Refrigeration was gone. Near misses by 8 more bombs had opened seams in her hull from frames 100 to 130 and ruptured fuel oil compartments. Admiral Chester Nimitz stood on the pier watching her approach, and he already knew something the shipyard didn't yet. Intelligence from Station Hypo, the cryptanalysis unit working in the basement of Building 1, had broken the Japanese naval code. The enemy was coming to Midway. 4 Japanese carriers, the finest naval aviators in the world, an invasion force that would change the entire trajectory of the Pacific War, and Nimitz had exactly 2 operational carriers to stop them, Enterprise and Hornet, maybe 3, if the shipyard could work a miracle. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The shipyard estimated 90 days to repair Yorktown at the Puget Sound Naval Shipyard in Bremerton, Washington. Nimitz looked at his chief of staff and said something that would echo through every emergency repair operation for the rest of the war. You have 3 days, not 3 weeks, not 3 months, 72 hours to patch a carrier that by every manual, every regulation, every engineering calculation should have been written off as combat ineffective for the next quarter. The Japanese were scheduled to attack Midway on June 4th. It was May 27th. What happened in those 72 hours wasn't in any technical manual. It was necessity writing its own doctrine, one welded seam at a time. C. The United States Navy in May 1942 had a problem they were just beginning to understand. Carriers were vulnerable in ways the pre-war theorists hadn't fully grasped. The doctrinal thinking before Pearl Harbor had treated carriers as support vessels. Battleships were the fleet's backbone. Carriers were scouts, eyes for the big guns. But 6 months into the war, with most of the battleship fleet still resting on the bottom of Pearl Harbor, carriers had become everything: strike platforms, fleet defense, power projection, and they were dying. Lexington had gone down at Coral Sea. Torpedoes and bombs, yes, but what killed her was fire, internal explosions from aviation gasoline vapors that the damage control teams couldn't contain. The carrier had survived the initial attack, was recovering aircraft, seemed like she'd make it home. Then gasoline fumes ignited in the ventilation system, and she was doomed. The loss of Lexington taught the Navy something crucial. It wasn't enough to build carriers that could absorb punishment. You had to build crews who could save them, and you had to develop techniques that could patch catastrophic damage under conditions that would make a peacetime inspector have an aneurysm. Yorktown arrived at Pearl Harbor on May 27th, 1 day ahead of schedule. The next morning, after Nimitz had cut orders voiding the safety regulation requiring a full day to purge aviation fuel tanks, Yorktown eased into dry dock number 1. The caissons closed behind her. Pumps began draining the water. With at least a foot of water still in the dry dock, men invaders gathered to inspect the hull. One of them was Nimitz himself, wading through oily water to see firsthand what his people were facing. The burst seams running along 30 frames of hull, the ruptured fuel tanks, the twisted metal where near-miss bomb blasts had hammered the ship's side. He turned to Lieutenant Commander Hay J. Pfinkstag, the hull repair expert, and repeated the order. 3 days. Pfinkstag gulped and said, "Yes, sir," because what else could he say? The alternative was sending Enterprise and Hornet to face 4 Japanese carriers alone. The Navy contacted Leslie Hicks, president of Hawaiian Electric Company. They needed power, enormous amounts of power for the welding work that was about to begin. Hicks arranged a series of rolling blackouts across Honolulu. Entire neighborhoods would go dark, so the shipyard could blaze with arc welders working around the clock. 1,400 workers swarmed into the dry dock. Shipfitters, machinists, welders, electricians, pipe fitters, shipwrights, the cream of Pearl Harbor, naval shipyard, and every civilian tradesman who could be pulled from other work. They brought with them something more valuable than their tools. They brought the lessons learned from 6 months of war. The welders, especially the welders, were about to write new rules. Captain Claude Gillette, the Pearl Harbor Yard superintendent, had already conducted a preliminary inspection while Yorktown was still en route. He knew what was coming. Standard procedure said, you repaired hull damage by cutting out damaged sections, fabricating replacement plates to exact specifications, fitting them precisely, then welding them in place with multiple passes to ensure structural integrity. There wasn't time for standard procedure. Instead of individually fixing the hull's ruptured seams, an enormous steel plate, one single massive patch, was fabricated to cover the entire damaged section. It wasn't pretty, it wasn't to blueprint specifications, but it would hold water, and that was all that mattered. The welders who did that work were violating about a dozen peacetime quality standards, single-pass welds in places that called for 3-pass reinforcement, plates that didn't match the original hull contours exactly, brackets welded in place without proper stress, calculations, emergency patches that would have gotten a shipyard worker fired in 1940, but this wasn't 1940, this was war, and the definitions of acceptable and impossible were being rewritten on the fly. The welders knew it. They kept working. The flight deck hole was easier, relatively speaking. Yorktown's own damage control teams had already patched it so cleanly during the voyage home that it appeared never to have been damaged. But the internal damage was another matter entirely. The bomb had exploded above the fourth deck, and its blast effects had rippled through compartments in ways that the original designers probably never imagined. Bulkheads were warped, deck plates were buckled, ventilation systems were compromised. The number 2 elevator mechanism was jammed. The shipyard workers attacked it all simultaneously. No careful planning, no detailed work orders, just crews of skilled tradesmen standing over Yorktown's original construction drawings, making decisions in real time about what could be fixed, what could be bypassed, and what could be ignored until after the battle. Whole sections of damaged plating were simply left in place and reinforced with welded brackets. Ventilation systems that couldn't be repaired were rerouted. The elevator mechanism that would have taken weeks to properly rebuild was patched well enough to operate. Maybe if the crew didn't push it too hard. This was field expedient engineering at a scale the Navy had never attempted, and it was all happening because of one inescapable fact. Midway was coming, and Yorktown was needed. The work continued through the night of May 27th. Welders perched on scaffolding, their arc lights casting weird shadows in the dry dock, the smell of hot metal and welding flux mixed with the ever-present stink of fuel oil. Electricians were rewiring systems using whatever cable they could scavenge from the yard's stores. Pipefitters were rerouting fuel lines around damaged sections. Machinists were rebuilding the elevator drive mechanism with parts that technically didn't meet specification but would probably hold together for a few weeks. That phrase, probably hold together for a few weeks, became the operative standard. Nobody was building for longevity. They were building for one more battle. Get Yorktown to Midway, let her launch her aircraft, bring her home. Then, maybe, they'd have time for proper repairs. The enormous steel plate covering the ruptured seams wasn't elegant, but it was welded solid. Divers had inspected the underwater work, declared it watertight enough. The phrase enough was doing a lot of heavy lifting. At 1100 hours on May 28th, dry dock number 1 was flooded. As water rose around Yorktown's hull, every welder, every inspector, every engineer watched for leaks. The patches held. Not perfectly. There was some seepage around the edges that would require continuous pumping, but the ship wasn't going to sink, and that was victory enough. Yorktown was towed into the harbour with workmen still aboard, still working. The ship wasn't finished. She was functional. There's a difference, and in May 1942, That difference was all that mattered. The techniques being used on Yorktown weren't technically illegal, but they violated every peacetime standard of naval construction. Welds that should have been X-rayed for quality control were done on visual inspection only. Patches that should have been pressure tested for days were declared good after hours. Structural repairs that should have been verified by naval architects were signed off by foremen who were making their best engineering judgment on the spot. In peacetime, this would have been a scandal. Ships had to be built to exact specifications. Lives depended on it. But this wasn't peacetime, and the greatest threat to American lives wasn't a welding defect. It was letting the Japanese take Midway and open the door to Hawaii. The welders knew they were pushing boundaries. Some of them were using techniques they'd learned during the Pearl Harbor salvage operations that had been ongoing since December. The salvage work had taught them things about emergency repairs that no manual could have predicted. How to weld underwater patches to seal torpedo holes. How to use wooden cofferdams to give you dry working space below the waterline. How to cut corners that wouldn't kill anyone but would get a ship floating again in a fraction of the normal time. Captain Homer Wallin, who was running the Pearl Harbor Salvage Division, had been preaching a philosophy since January. Perfection is the enemy of good enough. Do the work that needs doing, do it fast. Do it well enough to work. Worry about perfect later. That philosophy was now being applied to Yorktown, and every worker in that dry dock understood the stakes. On the morning of May 30th, more patched than repaired but fit enough to fight, Yorktown steamed out of Pearl Harbor. Workmen were still aboard, still making final adjustments as the carrier headed out to sea. Her air group was a composite drawn from 3 different carriers. Her hull patches were barely dry. Her repairs were held together by skill, speed, and the desperate hope that they'd hold long enough. 5 days later, she would help change the course of the Pacific War. But first, she had to survive the journey to Point Luck, the rendezvous coordinates where she'd join Enterprise and Hornet for the defense of Midway. And every welder who'd worked on her hull, every fitter who'd patched her bulkheads, every electrician who'd rewired her systems, would spend those 5 days wondering if their work would hold, wondering if cutting corners to save time had created new vulnerabilities, wondering if they'd done enough. The answer would come at Midway. But the real legacy of those 72 hours wasn't about one battle. It was about a complete rethinking of what was possible in emergency ship repair. The techniques used on Yorktown, the improvisations that would have horrified peacetime inspectors, would become the template for carrier damage control throughout the Pacific War. June 4, 1942, dawned clear over Midway Atoll. Yorktown was where Nimitz had ordered her to be. Task Force 17, flagship of Rear Admiral Frank Jack Fletcher, her patched hull was holding. Her jury-rigged systems were functioning. Her composite air group was ready to launch. At 06:05, Yorktown's radar picked up the incoming Japanese strike. Zeros and Val dive bombers, the first wave from the 4 Japanese carriers that had been detected northwest of Midway. The battle that would decide control of the Pacific was beginning, and Yorktown was about to prove whether 3 days of frantic welding and patching could hold up under combat conditions. But what happened at Midway wasn't just about Yorktown's patches holding. It was about what those patches represented. A fundamental shift in how the Navy thought about damage control, about emergency repairs, about what was acceptable when the alternative was defeat. The story of those 72 hours in May had already started spreading through the fleet, through every repair ship, every tender, every forward base in the Pacific. The word was getting out. Standard procedures were guidelines, not gospel. When lives and battles hung in the balance, you did what worked, not what the manual said. And sometimes, what worked was a massive steel plate welded over damaged hull sections by crews working in shifts around the clock, using techniques that would make a Bureau of Ships inspector weep. The welders who'd worked on Yorktown didn't know they were writing doctrine. They thought they were just doing a job under impossible time pressure. But their work, and the philosophy behind it, would ripple through every carrier operation for the Ferrisol, rest of the war. It would inform how the Navy approached damage control training, how they designed repair procedures, how they stocked repair ships, how they thought about what was possible when a carrier took damage and there was no time for perfect repairs. The Japanese, meanwhile, had no equivalent system. Their damage control was adequate for peacetime, adequate even for early war successes. But they hadn't learned the lessons that necessity was teaching the Americans. They hadn't developed the culture of improvisation, the willingness to violate standards in pursuit of survival that was becoming the hallmark of US Navy repair operations. That difference would matter. It would matter at Midway, when American carriers would prove more resilient than their Japanese counterparts. It would matter in the Solomon Islands, when damaged ships would limp to forward repair bases like Espiritu Santo and Noumea to be patched up and sent back into action. It would matter all the way to Okinawa in 1945, when carrier crews would save ships from kamikaze damage that should have been fatal. But in May 1942, nobody knew any of that yet. They just knew that Yorktown was heading to battle with patches that weren't in any manual, welded by crews who'd worked themselves to exhaustion because the alternative was unthinkable. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The morning of June 4, 1942, aboard USS Yorktown, the carrier's crew had been at battle stations 12 times in 6 hours. Japanese search planes kept probing the American task force, and everyone knew what was coming. At 0630, Lieutenant Commander Maxwell Leslie led Yorktown's dive bombers off the deck for the strike against the Japanese carriers. Below decks, in spaces that still smelled of fresh welding flux, damage control teams stood ready. They knew something the Japanese didn't. They knew exactly how fragile their ship was. Every patch, every jury-rigged system, every welded seam that had been completed in hours instead of weeks. They'd spent the voyage from Pearl Harbor testing, monitoring, watching for failures. The hull patches were holding, but they wept. Continuous pumping was required to keep bilgers dry. The number 2 elevator was functional, but temperamental. You had to baby it, coax it through each cycle. The ventilation system had hot spots where damaged ducts couldn't be fully repaired. The ship worked, but she worked hard. At 1100 hours, Yorktown's lookouts spotted them. 18 Aichi D-3 Aval dive bombers, escorted by 6 Zeros. The Japanese carrier Hiryu's strike force, coming for revenge after American bombs had destroyed 3 of Japan's 4 carriers that morning. Yorktown's combat air patrol, her fighter screen, intercepted. They shot down several Vals. But war isn't perfect, and some got through. At 11:02, the first bomb hit, 550 pounds of high explosive striking the flight deck, penetrating to the 4th deck before detonating. Almost exactly where the Coral Sea bomb had hit 3 weeks earlier, the blast killed or wounded 61 men. It started fires on 3 decks. It knocked out the boilers in fire rooms 1, 2, and 3. Yorktown lost power, lost speed, began listing. The damage control teams went to work, and this is where those 3 days at Pearl Harbor mattered, not because the patches held the ship together, but because the crews had learned something from watching those shipyard workers improvise solutions under impossible time pressure. They'd learned that the manual was a starting point, not a limit. Lieutenant A.C. Emerson, leading Repair 2, started fighting the fires using techniques that weren't exactly by the book. When standard fire hoses couldn't reach the blazes because the passageways were blocked by debris, his teams rigged jury lines through ventilation shafts. When power to the foam generators failed, they manhandled CO2 bottles into position and manually discharged them into the flames. Lieutenant Commander John Greenbacker, the damage control officer, made a decision that would have gotten him questioned in peacetime. He ordered steam lines cross-connected in ways that bypassed damaged boiler rooms, routing power through systems that weren't designed for that kind of load. It worked. By 11:44, 76 minutes after the bomb hit, Yorktown was recovering aircraft. Her speed was back up to 20 knots. Her fires were controlled. She was wounded, yes, but she was fighting. The Japanese pilots who'd attacked her reported back to Hiryu that they'd left an American carrier burning and dead in the water. They thought they'd killed her. Then, at 1400 hours, Hiryu launched a second strike. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. 10 Nakajima B, 5N Kate torpedo bombers, escorted by 6 Zeros. These pilots were the elite of Japanese naval aviation, veterans of Pearl Harbor, veterans of the Indian Ocean raids. They'd sunk more ships than most nations had in their entire navies. They approached Yorktown and saw a carrier steaming at 20 knots, flight deck clear, launching fighters. They thought it was a different ship. The carrier they'd bombed 2 hours earlier couldn't possibly be operational. But it was Yorktown. Patched, battered, jury-rigged Yorktown. Still fighting, the torpedo bombers came in low, threading through anti-aircraft fire that filled the sky with black bursts and tracer rounds. They were good. They were very good. At 14:22, torpedoes struck Yorktown's port side. The hull patches that Pearl Harbor workers had welded in place 72 hours held. They didn't fail, but torpedoes are different from bombs. They're designed to break a ship's spine, to flood compartments faster than pumps can handle, to create progressive flooding that dooms even the best damage. Control. Yorktown took on water. Her list increased to 17 degrees. Power failed across multiple systems. The damage control teams fought, but physics was against them. At 1500 hours, Captain Elliot Buckmaster ordered abandon ship. But here's what mattered. Yorktown didn't sink. Not that afternoon, not that night, not the next day. She stayed afloat, listing but floating, while her crew evacuated, while destroyers pulled survivors from the water, while the battle raged on around her. The next morning, June 5th, a salvage team returned to Yorktown. They found her still afloat, still savable. They got pumps working, started reducing the list, began patching new holes. For 2 more days they fought to save her. She might have made it too, except for the Japanese submarine I-168. On June 7th, that submarine put 2 more torpedoes into Yorktown's hull and 1 into the destroyer Hammond alongside. That was finally too much. At 0700 hours, June 7th, 1942, USS Yorktown rolled over and sank. But she'd done her job. Her dive bombers had helped destroy the Japanese carrier Soryu. Her fighters had defended the task force. And most importantly, she'd absorbed 2 separate Japanese strikes that could have been aimed at Enterprise or Hornet. She'd been a target that refused to die, drawing fire, staying in the fight, giving her sisters time to strike back. The welders who'd patched her at Pearl Harbor had bought the Navy 72 hours to get her to battle. The damage control teams had bought her 2 more days beyond what should have been possible. Together, they'd changed history. But Yorktown's story was just the beginning. The techniques used in those 3 days at Pearl Harbor, the philosophy of good enough is good enough, started spreading through the Pacific Fleet like wildfire. Captain Homer Wallin, who'd been directing the Pearl Harbor salvage operations, had already been applying these principles to the battleships sunk on December 7th. Nevada, California, West Virginia, ships that conventional wisdom said would never fight again. Wallin's teams were raising them using methods that would have been unthinkable in peacetime. Wooden cofferdams built around torpedo holes to create dry working spaces, concrete and timber patches over blast damage, welded steel boxes sealed around cable penetrations in bulkheads to stop flooding, divers working in oily water filled with hydrogen sulfide, cutting and welding below the waterline, using techniques that were being invented as they went. When Nevada was refloated in February 1942, the Navy learned something crucial. Ships could be saved if you were willing to throw out the rulebook. By the time Yorktown went to Midway, that lesson had been internalized. But it wasn't just about salvage. It was about changing how the Navy thought about damage control training. Lieutenant Harold J. Burke, a Navy reservist who'd been deputy chief of the New York City Fire Department, was brought in to revolutionize firefighting doctrine. His experience fighting real fires in real buildings, where you didn't have time for by-the-book procedures, translated perfectly to fighting fires on damaged warships. Burke's philosophy was simple: train every sailor to fight fires. Not just designated damage control teams, every single person aboard. Because when a carrier takes a bomb or a kamikaze, you don't have time to call for specialists. You need the cook, the radio man, the pilot who just landed to grab an extinguisher and start fighting. By mid-1942, this training was becoming standard. Boot camps added extensive firefighting instruction. Ships held regular damage control drills where crews practiced fighting fires, patching holes, rerouting systems. The drills were realistic, sometimes dangerously so. Ships would set actual fires, flood actual compartments, force crews to work in smoke and darkness and chaos, because that's what combat damage looked like. The equipment improved too. The carbon dioxide systems that Yorktown used at Coral Sea to purge gasoline lines became standard on all carriers. Machinists mate Chief Myers, who'd innovated that technique aboard Yorktown, had inadvertently saved countless lives. Admiral Nimitz noted in his Midway report that gasoline fires in carriers were a serious menace, but Yorktown had no gasoline fires despite 3 bomb hits, possibly because of effective CO2 use. That innovation spread instantly. Fire mains got redundancy. The Essex-class carriers, designed with 14 fire mains dependent on ship's power, added 2 additional mains powered by independent gasoline engines. Foamite systems were installed every 100 feet on all carriers. Ring main designs put one fire line high and the other low on opposite sides of the ship, so a single hit couldn't take out both. Every lesson learned in combat was being engineered into new designs, but more importantly, it was being retrofitted into existing ships. Repair ships, like USS Vestal, became floating factories of innovation. Vestal had been damaged at Pearl Harbor, moored alongside Arizona, when the battleship exploded. Her crew had fought their own damage while simultaneously sending repair parties to help other ships. After Pearl Harbor, Vestal became a legend in the South Pacific. She completed over 5,000 repair jobs on 279 ships in one 12-month period at Espiritu Santo. Some of those jobs were routine, replacing worn machinery, fixing electrical systems, standard maintenance. But some were battlefield repairs that redefined what was possible. Heavy cruiser San Francisco, ripped by heavy caliber hits during the night battle off Guadalcanal. Light cruiser New Orleans, with a torpedo hole measuring 24 by 40 feet and 2 propeller shafts broken. The New Zealand cruiser Achilles, with a direct hit on her after turret. Vestal's welders, fitters, and machinists worked miracles on these ships. Not perfect repairs, not shipyard quality work, but repairs good enough to get them back into action. The philosophy was spreading: do what works, do it fast, worry about perfect later, if there is a later. By 1943, the Navy had formalized some of these emergency procedures, but formalization didn't mean restriction. The new technical orders and damage control manuals emphasized flexibility. They taught principles, not recipes. How to assess damage, how to prioritize repairs, how to improvise solutions using whatever materials were available. One technical order from late 1943 contained a passage that would have been heretical in 1940. Quote, "When standard repair materials are not available, use lumber, mattresses, concrete, or any substance that can create a watertight seal. The goal is to control flooding and keep the ship fighting. Perfection of repair is secondary to speed and functionality." End quote. That was official doctrine now, in writing. Approved by the Bureau of Ships, the same bureau that, before the war, would have fired a welder for using a single-pass weld, where regulations called for 3 passes. The evolution of carrier damage control reached its pinnacle in 1945. By then, American carriers were facing the kamikaze, suicide aircraft loaded with bombs and fuel deliberately crashed into ships. Kamikazes were terrifying. They were also, paradoxically, survivable. USS Franklin, an Essex-class carrier, was operating 50 miles off the Japanese coast. closer than any American carrier had operated during the entire war. She was launching strikes against the homeland when a single Yokosuka D-4Y Judy dive bomber pierced the cloud cover and dropped 2 semi-armor-piercing bombs. Both hit. One struck the flight deck centerline, penetrated to the hangar deck, detonated among fully armed and fueled aircraft. The second hit aft, tearing through 2 decks. What followed was a holocaust. Bombs cooked off. Tiny Tim rockets, 11.75-inch monsters designed to kill battleships, ignited and screamed across the deck. Aviation gasoline from ruptured tanks fed fires that reached thousands of degrees. Franklin was 50 miles from Japan, dead in the water, listing 13 degrees, with no radio communications and 832 men dead or dying. She should have sunk. Every calculation said she should have sunk, but she didn't. The damage control teams that saved Franklin were using techniques that had been developed over 3 years of war. Techniques that traced their lineage directly back to those 72 hours when Yorktown was patched at Pearl Harbor. They fought fires using improvised equipment when standard gear failed. They jury-rigged power systems to restore critical functions. They patched holes using whatever materials were at hand, including wooden shoring and welded steel plates that would have made a pre-war inspector weep. Lieutenant Donald Gary, who would later receive the Medal of Honor, led 300 trapped men to safety through smoke-filled compartments by breaking through bulkheads that weren't supposed to be breached. Lieutenant Commander Joseph O'Callaghan, the ship's chaplain, organized firefighting parties and led men below to wet down magazines that threatened to explode. He'd later receive the Medal of Honor too. The light cruiser Santa Fe came alongside and took off hundreds of wounded. The heavy cruiser Pittsburgh took Franklin under tow. And somehow, impossibly, Franklin's engineers got one boiler working, then another, until she was making 14 knots under her own power. She steamed 12,000 miles, Ulithi to Pearl Harbor to the Panama Canal to Brooklyn Navy Yard. Under her own power, with damage that war damage reports would later describe as the most severe sustained by any carrier that survived the war, 807 dead, more than any surviving U.S. warship except Arizona, but she survived, the ship that wouldn't die. Franklin's survival wasn't luck. It was the culmination of everything the Navy had learned about damage control since Yorktown's emergency repairs in May 1942. It was training that made every sailor a firefighter. It was equipment designed with redundancy and survivability in mind. It was a culture that valued results over procedures, survival over standards. By war's end, the statistics told the story. 5 U.S. fleet and light carriers were lost during the war. Lexington, Yorktown, Wasp, Hornet, Princeton, 4 of those 5 were lost to fire and secondary explosions, not to the initial damage. But dozens of other carriers were hit, damaged, set on fire, and survived. Saratoga survived kamikaze hits that killed 123 men, but was back in action after repairs. Bunker Hill survived 2 kamikazes in 30 seconds that killed 396 men. Enterprise survived multiple bomb and kamikaze hits throughout the war. Intrepid earned the nickname the Fighting Eye after surviving 4 separate kamikaze strikes and continuing operations. These ships survived because of damage control excellence that had been forged in the desperate days of 1942. The British Pacific Fleet, operating alongside American carriers in 1945, learned these lessons firsthand. British carriers had armoured flight decks, which provided excellent protection against bombs, but they had less sophisticated damage control compared to American practices. After seeing how American crews fought damage, how they improvised, how they saved ships that by British standards should have been abandoned, the Royal Navy started adopting American techniques. The contrast with Japanese carriers was even more stark. Japanese damage control remained adequate for almost peacetime but fatal in war. Their fire suppression was limited. Their damage control training was restricted to specialists rather than all hands. Their repair procedures were rigid by the book, with little room for improvisation. At Midway, the 4 Japanese carriers that were destroyed all succumbed to fire. Akagi, Kaga, Soryu, Hiryu. Each took relatively few bomb hits, but their firefighting was inadequate, their damage control unable to contain the blazes, their aviation fuel and ordnance storage insufficiently protected. American carriers taking similar damage survived. That difference, more than anything else, determined control of the Pacific. The American carriers could take punishment and keep fighting. The Japanese carriers couldn't. After the war, the Navy commissioned studies to understand what had worked and what hadn't. The reports made fascinating reading. They praised the improvisation and flexibility that had saved ships. They recommended that emergency repair procedures continue to emphasize speed and functionality over perfect compliance with peacetime standards. But they also noted something important: the willingness to cut corners, to use good enough solutions had come at a cost. Some quick fixes had created long-term problems. Some improvised repairs had failed, causing casualties. The balance between desperate urgency and reasonable caution was delicate. The post-war Navy tried to capture that balance in new training programs and technical manuals. They institutionalized improvisation, which sounds like a contradiction but was actually brilliant. They taught principles of damage control that emphasized understanding systems well enough to improvise when necessary. They stocked repair ships with diverse materials, so improvisation wouldn't require scavenging. They designed new ships with damage control in mind from the keel up. The Midway-class carriers, designed late in the war and completed just as it ended, incorporated every lesson learned. Armoured flight decks like the British, fire suppression systems that went beyond anything previously installed, compartmentation that limited progressive flooding, multiple redundant systems for critical functions. These ships were designed to survive the kind of damage that would have sunk pre-war carriers. But more than the engineering, the post-war Navy preserved the culture, the understanding that manuals are guidelines, that intelligence and improvisation matter more than rigid compliance, that a ship that keeps fighting, even when damaged, is worth more than a pristine ship at the bottom of the ocean. The welders who'd worked 72-hour shifts patching Yorktown in May 1942 never knew they were creating doctrine. They thought they were just doing a job under impossible conditions. But their work, and the philosophy behind it, rippled through the entire Pacific War. It informed how carriers were designed, how crews were trained, how battles were fought, and when Yorktown finally sank on June 7th, after surviving 2 separate air attacks and staying afloat for 3 days when she should have gone down in minutes, those welders could be proud. Their hasty patches, their violation of peacetime standards, their embrace of good enough had bought the Navy time. Time for Yorktown to fight at Midway, time for her dive bombers to destroy Soryu, time for the U.S. Navy to win the battle that changed the war. The Japanese had faster carriers in some cases, better aircraft early on, more experienced pilots, but they never developed the damage control culture that the Americans forged in the desperate days of 1942. They never learned to improvise, to violate standards in pursuit of survival, to embrace good enough when perfect wasn't possible. That difference, as much as any weapon or tactic, determined who would control the Pacific. By war's end, American welders and damage control teams had developed techniques that seemed impossible in 1940. Underwater welding to patch holes below the waterline, cofferdams to create dry working spaces in flooded compartments, jury-rigged power systems that kept ships fighting, emergency patches that held together for months. These techniques weren't in any pre-war manual. They emerged from necessity, from intelligent men and women facing impossible situations and refusing to accept defeat. The legacy of those 3 days in May 1942 lived on in every carrier that survived damage during the war. In Franklin steaming 12,000 miles with catastrophic damage. In Bunker Hill recovering from 2 kamikazes in 30 seconds. In Enterprise earning 20 battle stars, despite being hit repeatedly. In Intrepid surviving 4 separate kamikaze strikes. Every ship that should have sunk but didn't owed something to the philosophy established in those 72 hours at Pearl Harbor. Do what works, do it fast. perfection is the enemy of survival. The men who saved these ships, the welders and fitters and damage control teams, operated in a tradition that valued results over procedures. They understood that war makes its own rules, writes its own manuals, and survival goes to those who can adapt fastest. In 1968, retired Vice Admiral Homer Wallin published his memoir of the Pearl Harbor salvage operations. He titled it Pearl Harbor, Why, How, Fleet Salvage and Final Appraisal. In it, he wrote about the philosophy that had guided his work. Quote, "Enough cannot be said in praise of the salvage crew. They worked hard and earnestly. They soon saw that the results of their efforts exceeded the fondest hopes of their supporters, and they were urged on by their successful achievements." End quote. That spirit, that willingness to attempt what conventional wisdom said was impossible, defined American naval repair operations throughout the Pacific War. It saved ships, it saved lives, it changed history. The techniques, pioneered in those desperate days, became standard practice. The improvised solutions became official procedures. The violations of peacetime standards became wartime doctrine. And the legacy endures. Modern U.S. Navy damage control still emphasizes the principles learned in World War II. Flexibility over rigidity, results over procedures, survival over perfection. When USS Cole was bombed in 2000, when USS Fitzgerald was damaged in a collision in 2017, the damage control teams that saved those ships were using techniques that traced their lineage back to May 1942. Back to welders working around the clock to patch Yorktown, back to damage control teams fighting to save Franklin, back to salvage crews raising Nevada from Pearl Harbor mud. The story of carrier survival in the Pacific wasn't about one welder's illegal technique. It was bigger than that. It was about an entire navy learning to improvise, to violate standards when survival demanded it, to embrace good enough when perfect wasn't possible. It was about 1,400 workers patching Yorktown in 72 hours, about damage control teams saving Franklin from damage that should have been fatal, about a culture that valued fighting ships over perfect ships, survival over compliance. And it worked. American carriers dominated the Pacific not just because they were well designed or well armed, but because they refused to die, because their crews had learned lessons forged in desperate circumstances. Lessons about damage control, about emergency repairs, about what's possible when the alternative is defeat. Those lessons, purchased in blood and fire across 3 years of war, remain relevant today. The names have changed, the technology has evolved, but the principle endures. When a ship is damaged and lives hang in the balance, you do what works. You improvise, you adapt, you overcome. The welders who patched Yorktown never sought glory. The damage control teams, who saved Franklin, weren't looking for recognition. They were doing their jobs under impossible conditions, making decisions in real time, creating solutions that defied conventional wisdom. And in doing so, they wrote doctrine that would save countless ships and thousands of lives. Yorktown's patches held long enough for her to fight at Midway. Franklin's crew kept her afloat for 12,000 miles. Countless other carriers survived damage that should have been fatal, all because of a philosophy developed in the desperate spring of 1942. Good enough is good enough. Speed matters more than perfection. And sometimes, violating the standards is the right thing to do. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.